Hello all. Now look, for some this video might be a bit dry. For that I can only apologise, but the aim here was to try and provide a sort of reference for making my routing machine or one like it. Regulars may be familiar with the machine. It's appeared in a number of my videos. It's a manual 3-axis routing machine I call just that, the routing machine. The magnum opus of my tool hacks, if you will. In this video, I'm going to share with you the parts list I've created for it, and as I've recently dismantled it for an overhaul and service, some instructions on putting it together. It's a video I've been meaning to do for a long time. A niche video perhaps, but for those interested, it should demonstrate something like it can be made without any special skill set or tools. If you're new to the channel or not seen me use this machine before, I'd recommend you first watch this video where I talk in more detail about the machine, how I use it and for what, as well as talking about the attachments I made for it, including fences, copy pin, 4th axis for turning, and a tilting angled bed for milling miters with mortises for my furniture. I'll link that video below and make sure it pops up at the end. Coming up, I'll get straight into the parts list. I'll cover construction of the basic machine. By basic machine I mean what you see here, not the attachments, and look at servicing and or conditioning the bearings, something you may need to do even with new rails and bearings. Before we get started, the disclaimer bit. The content of this video is meant as a rough guide to help you realistically plan for your own machine. My machine has been through many iterations. I will try and create a playlist for all of those, and has been, and still is really, a learning experience for me. So what follows is not a definitive guide to a perfect machine. If you build a machine based on the information I provide here, its success is entirely on you and the care you take selecting parts, setting them accurately, and even adjusting or tweaking parts if necessary to work as desired. All that said, I wouldn't be without a manual routing machine now, even if I had room for a dedicated CNC. Not having to program for bespoke milling, turning and surfacing or flattening jobs makes even my niche requirements for my furniture quite efficient. Plus, unlike a CNC which needs a dedicated bench due to the sensitivity of some of its components, my robust manual machine is happy being slung on the wall out of the way when not in use, so perfect for small shops. Here you can see what I'm defining as the X, Y and Z axis. X is length, Y is width, and Z is up and down. I won't have PDF or printable plans available. My advice is to, on a laptop or phone, just pause and screenshot the parts lists. From there, you can print them or do whatever you will. Starting with the base, all the parts highlighted here, parts list is as follows. For the Y-axis gantry, parts highlighted here, parts list is as follows. For the Z-axis headstock, parts highlighted here, parts list is as follows. If you're in the UK, I recommend getting your profiles from Ooznest, as they offer an excellent cutting and tapping service you opt for when adding to the basket. The tapping is applied to the profile ends and in M5. Ooznest I'd also recommend for the router mount. They sell the mount with or without the brackets, but I'd get it with, as they're good quality genuine 90-degree brackets. For the mount, they offer 3D printed collars. For my Mafel, I had the 43mm collar, but if you enter your router body outside diameter, as long as it's under 71mm, they'll print to suit. I think it'll accommodate the likes of the Makita and DeWalt trim routers, but not the Bosch. Where I refer in the parts list to the 4080 T8 lead screw C-beam assembly, I'd recommend to just Google it and look for good deals. You'll find something like this one on Amazon. It saves an awful lot of hassle buying it as an assembly rather than ordering all the individual parts. Mine has been upgraded with linear rails though, which I'll cover as we work through the build. The linear rails are the square type, and it's the 12mm that I use, known as MGN12s. Now these can get a little expensive, and there is an element of you get what you pay for with these, but I've been managing fine with these fairly cheap ones from Banggood. Lots of length options, and you can order extra bearing blocks. Do double check when ordering whether each rail comes with a block or not, and if you need to order extra to give you 2 blocks per rail. Depending where you order from, some listings will sell the rails without blocks or with 2 already on it. My MGN12 rail and block combined height is about 13mm, but I'd recommend these rails being the first thing you order to make sure dimensioning for the profiles is correct, for the C-beam gantry in particular. Some links to these things will be provided below. The rails and bearings are a good place to start the build and service part of the video, I think. My machine largely disassembled here, bearings showing every sign of working solidly for 2 years without service. When you buy new rails and bearings, especially budget ones, you'll need to degrease the factory stuff, clean and re-grease for smooth running before using an earnest. It's an easy enough job, but quite involved, and there's plenty of videos on servicing and conditioning budget bearings on YouTube, but as I was doing it, I have included this anyway. It's advisable to degrease and clean the rails themselves too. If when new your blocks are not smooth or free running, try going in the bearing groove with small bits of 500 grit sandpaper. In the parts list you'll see a number of M3 hex screws, that's these things. For use with an Allen key, they'll drop into the counter bore in the rail. I refer to M3 hex bolts in the parts list also, which are these. I prefer these ones for mounting the alley plates to the blocks. They can torque up a little more than the tiny Allen screws. Not an issue for the rails given the sheer number of screws they'll take. So do each bearing block individually. You can see here I've got a dish, a cloth, a craft knife, a magnetic tip screwdriver and a precision screwdriver. With the precision screwdriver, undo the small screws at each end and remove the red end cap. You'll notice when you take it off it has 2 small protrusions to locate it in the green section. Keep holding the block over the dish as when off the rail the odd bearing may drop out. The red piece is removed at both ends, you're able to remove the retaining wire. At each end, the wire is formed into a sort of L shape that hooks into recesses in the green parts. Using the tip of a craft knife, unhook the wire. Be careful when you do this. You don't want to ping it off suddenly and have the wire and bearings go everywhere. It might take a few attempts, but just ease the wire off gently and allow the bearings to fall into the dish. With both wires removed, you can completely dismantle. Be mindful the bearing race is like a dual carriageway. They go around the front, those you can see, loop through the green plastic sections, through a tunnel inside the block. Just make sure the green parts and the blocks are empty of bearings so as not to lose any when cleaning. You can use specialist degreasers at this point, but I just drown the parts in WD-40. This is fine for the task, but just remember, while it shifts muck, it's residue too when in cleaning or drying off. Some cotton buds and a cloth are fine for this. If there's stubborn muck in the green parts, they can be popped apart quite easily. When they're apart, you can see the clever little loop for the bearings moulded in and how the central hole going through this and the red piece would flood this end with grease or oil for lubricating. When clean and dried, just snap back together. I use the magnetic screwdriver to shift the bearings to the cloth along with the pins. I then fold the cloth and roll it around a little to dry the bearings. To rebuild, it's, I guess obviously, disassembly in reverse. Seat the green parts in position on the blocks, there are locating pins to help with this, then reseat the retaining wires. Most will seat pushing them into place by hand, but if they're not quite there, encourage them with the tip of the craft knife. The wire should feel flush at each end and not show any funny bowing along the bearing race. Seated nicely, the red end caps can be reattached. I tend to do the screws up, then back them off a little for now. These end caps have little bits that stick out, clearing the grooves in the rail as they go. I wait to fully tighten them till they're actually on the rail. I can't remember now, but I think it was 32 ball bearings or something per side in these blocks. Either way, you'll know when each side is full, as you'll be left with a 1 bearing gap each side. You can load 1 or 2 at a time quite easily with the magnetic screwdriver. As you add them, roll them along through the loop. Do this carefully though, they can pop out of the race again quite easily. When both sides of the block are full, slide in one of the plastic dummy rails. These come with separately purchased blocks and are so useful. I'd recommend buying a rail with 1 block and buying a second separately just because it will come with these. It means you can store the blocks without losing bearings while cleaning the others, or just simply making it easier to load blocks onto the rails proper. Loaded onto the rail, I flip upside down and give the bearings a dose of oil. There are specialist greases for this application available and preferred oils. I'm not too precious about it and I just use 3-in-1. I prefer oil to grease simply because I found fine dust and grease don't play nice at this scale. For me, oil just seems to work so much better. It's easier to add on the fly and makes rail and bearing maintenance easier. And I use the 3-in-1 simply because it's always in the shop and readily available, so can be used liberally and often. So the first stage of the build is to set your rails on their appropriate profiles. This means adding, loosely, all the M3 screws and sliding T-nuts for each hole beforehand. When they're in place, slide it into the profile. This in itself can be a bit of a chore. You may have to back the odd screw off a little and, as you go, you have to align every T-nut to the slot. But trust me, better this than trying to locate all those screws to T-nuts after the fact. In position, it's time to set and screw down. You can quite easily set position by setting a T-type gauge or a combi square working your way along the rail. Here, because I have it available, I'm using my dial indicator. It held to the profile with an Allen screw and M5 sliding T-nut. I tighten a screw at one end first, making sure the rail is flush to the end, then move the dial indicator over that screw position to zero it. Indicator zeroed, I loosen its mount screw and move 2 or 3 rail screw holes along. Refix, then adjust the rail with a bit of lift to zero on the dial, then tighten the next rail screws, and repeat along the rail length. Here I'm demonstrating the same process with a T-type gauge, which could just as well be a combi square, just showing that in this instance it's easier to set laid flat. I'd set the gauge here to match the rail I'd just done with the dial. Either way, the important thing is to make sure the rails on each side are positioned exactly the same and mirroring each other. Here's an animation of what's coming next, assembling the machine, hopefully helping you visualise what I'm doing. The only difference being that real world, you fit the rails prior to assembly as we've just seen. On the zero planer beds here, as they provide a reliably flat surface, I have the 1 metre lengths for the base side and one of the 640mm pieces that make up the front and rear of the base. You can see I've joined 2 profile pieces to give me the required 2060 profile dimensions. Don't worry about that, that was just needs must on my part. I have a corner plate already attached. Have it loose in position so the end 3 holes will align to the tapped holes in the end of the rail. When in place, keeping everything flat, start tightening down. I sized the corner plates at 58mm height to give 1mm of top and bottom clearance. You don't need to worry about square yet, just keep it flat and tighten down. Then the same the other end. Important to mention that when assembling, remember to add sliding T-nuts to the appropriate slots before closing the ends off. So here you'll see I have the T-nuts for the central 180mm 2060 profiles, but also some in the top of the 1 metre long side profile. These ones in particular for adding attachments in operation. All the internal pieces in the base are fixed via the 40 by 20mm corner brackets in the parts list. I attach them loosely to the short pieces first, then locate the T-nuts in the frame perimeter. Set the position, then lock down, again taking care to keep it flat to the planer bed. The 2 180mm 2060 profiles in place, I can add one of the long 960mm 2040 central pieces. You'll notice all the T-nuts for assembly and those on top for attachments in operation are already in place. If you prefer, you could use 2060 profiles for these. I use 2040, as for me it opens up some clamping options when on the bench, using the sort of clamps you'd use through the 20mm holes in an MFT bench. I set them on a couple of scraps of 2020 profile so their tops sit flush with the rest of the base frame. It's at this point it becomes important to square every subsequent fixing. The brackets never seem to be truly 90 degrees, so set up some squares, clamp down and true as you go. It's a bit fiddly getting things together, but I do 1 screw of each side of the bracket up first, check everything, then tighten up the second pair. With a short piece set, I move the square and fix the long rail nearest to it. The brackets all inside the squares I'm forming, leaving a clear, uninterrupted channel down the centre of the base. This, I find, leaves me lots of practical working options. Worth reiterating again that every fixing is checked and double checked for flatness, position and squareness. It's worth spending time getting it as good as you can. It will pay dividends further down the line. You can always cut spacers to help you lay things out. Use them to set position, then clamp and remove the spacer to access the screws. All being well, you'll end up with a frame that, wherever you put the square, it's square. For the rest of the base, it's just rinse and repeat of what you've just seen. Do the same as you've seen the other end, then the same the other side. Base frame complete. You can see I've attached my bearing blocks loosely for now to the 150 by 245mm alley plates. Also note that dummy rails are in place to stop any of the ball bearings going walkabout. They also help you align to the main railway to slide on. Just take a little care doing this so as not to expose the bearings and potentially lose any. There is a little room for play in the hole sizing, some 0.5mm on my plates, but they still need to be squared. You don't want to find yourself at the limits of adjustment later on. As mentioned, when doing the bearings, you'll notice it's the little M3 12mm hex bolts. They are small, but allow you to tighten them a good deal more than the hex screws used on the rail, whose heads can strip quite easily. Here I've got the Z-axis assembly, cleaned and bearings serviced. They come with a little gantry plate with V-groove wheels as standard, but as you can see, that's been replaced on mine with the linear rails. The original plate attaches to the anti-backlash nut, stood off by 2 washers just to clear the back of the C-section profile. Obviously, the rails and blocks need a longer standoff to attach the new gantry plate to the anti-backlash nut. I used the 9mm and 6mm spacers combined from the parts list to create the required standoff. These available from Ooze Nest. This anti-backlash nut needs fixing to the gantry plate first, and to do so, it and the lead screw need removing from the C-section. I put the two 40mm M5 hex screws through the gantry plate and slide on the spacers, then marry them to the anti-backlash nut and tighten down, but not fully. Then the assembly can be put back together. C-section end stops first, then the bearings can be aligned and screwed down, once again just not fully tightened yet. With the base of the C-section sat on the bench, I have a square against the side of the gantry plate. Happy it's sat square, all the bearing bolts at the rear get tightened fully. Happy they're all tight and the plate is seated correctly, the screws of the anti-backlash nut can be tightened. We're getting there now. Attention can now be turned to the gantry. Bearings and rails already on it, the large gantry plate offers good access to the holes for the bearings. The bolts are put in place and left loose. I then mount the gantry to the edge of the bench and, with a digital level box 0 to the top of the gantry, I adjust the Z-axis until it reads 90 degrees and then cinch down. I have just one bolt in each bearing block to simplify this, as you'll tighten, check, reset, tighten and check a few times. Again though, worth getting right, which you'll have to trust me was the case, as the camera didn't actually pick out the reading at this angle. Last main step of the build is attaching the gantry assembly. As with all the previous assemblies, seat in place, then loosely put in the mounting screws. I recommend cutting a couple of spacers at correct height to seat the gantry on while you adjust. Level box this time 0 to the top of the side of the base frame. I set it against the face of the C-section to check for 90. Like before, you might find you'll tighten down, only to find doing so has pulled your readings out of whack. But take your time, loosen off and set it again. You'll get there eventually. At this stage, it's really what you make of it in terms of dialing it in. You want the face of the gantry 90 degrees to the frame pieces running the length. It also needs to be sat at equal height each side of the base, and like here, you want to 0 at the base and have that carried through to the gantry and the motor mount. I think that covers it then for the main build. What you add for functionality is up to you and your imagination from there. A couple of fundamental finishing touches before I go. First would be stops at the end of every way. The stops I'm using here I made from 20mm aluminium round bar. I use it on my furniture, but you may have watched me use the same stuff on a recent video making flag stops for my MFT fence. Being round stock, it nestles in the profile slot perfectly every time. It's ideal really. Just a hole through it for an M5 thumb screw and a sliding T-nut on the end. These are important not just to stop the blocks flying off the rails, but also for setting position. That could be locked in place or set between a defined distance, so an essential on such a manual machine. Atop the Z-axis, the assembly will come with a connector usually. Mine is the springy type, but there are fixed or solid ones too. Meant to connect to a stepper motor, I just have an M8 bolt through this star knob attached to it. Works fine for me, but you could maybe use a hand wheel or whatever. I do the anti-backlash nut we saw earlier up quite tight. This not only does away with slop when you turn the knob in different directions, but adds resistance, stopping the headstock from descending under its own weight. On that point, just like the X and Y axis having their stops, I have a stop on the Z axis too. This essentially the same thing you'd see on any plunge router, just a rod you can lock off at certain depths. I made mine by drilling out the centre hole in a scrap of 2020 profile for the 6mm steel rod. As mentioned at the start, getting the most out of the machine means making various attachments. The most used for my furniture is this angle attachment, and to see the other attachments, do watch the previous video on this machine. I tend to not use a spoil board on mine as it is, but have on previous iterations, and you never know, may well do again. It comes down to your needs really. As to costs to build the thing, I mentioned it in the previous video, but you'll be looking at £500 to £600 for the basic machine, and that's with no motor or attachments. You could spend a lot more than that using higher quality or larger rails. Another thing that could add cost is getting your aluminium plates machined. Lots of independents on eBay that offer just such a service. The benefit there is you could get them to not only drill accurate holes, but also get them to surface and flatten the plates. If I build another one, that's what I'll be doing. A stock alley plate tends to come not square and not dead flat. Still, I used my aluminium in stock condition and hand drilled all my holes, and the machine is perfectly functional. It's so good in fact, I use it to mill all my furniture miters, as the miter saw and table saw just can't compete when you're after perfectly connecting components. So if you've ever thought about making a machine like this, I hope you found this helpful and maybe it spurs you on. If you've no intention of making one but watched anyway, good on you, and I hope you found it interesting. Please hit like if that's the case and sub if you aren't already. If you appreciate the information provided here, you can buy me a pint by using the thanks button below. Talking of which, have you seen the price of beer in the pubs lately? £7 for a light ale round my way. It's a scandal, isn't it? Anyway, I best not get started. So as ever, if you made it this far, thanks for watching.